It's simply conversion from metric to imperial, or metric to metric, or imperial to imperial. So today, all we're adding to this dynamic is surface area and volume. Now, your sheet that I gave you with all the conversions on it, on the other side of that sheet, gave you all the equations for surface area and volume of a variety of different shapes. So basically all I want to do today is you're going to continue to use your conversions as well. You're going to add in the area and the volume to it. So for a friend's birthday, Sam plans to wrap the door of her locker with wrapping paper and fill the locker with balloons. The dimensions of the locker are shown. How much wrapping paper will he need to cover the door? Okay, so got a locker. This is 1.05 meters, right? It's a 30 across the bottom and 40 deep. So the first question says to us, how much wrapping paper is you need to wrap on the door, right? So I need to find the area of the door. How do I find the area of any rectangular object? Length times width, right? So my length in this case is 30 centimeters. What is my width? What's my width of that door?
30.
No. I'm looking at the door right here.
1.05.
1.05 meters, right? But I don't want to work in two different units. So let's change the meters to centimeters. So how many centimeters is that?
105.
105. Now, in the last section, I like to see all the conversions being done. In this section, all I need you to do is be able to do the conversions correctly. So if you don't want to write all that out, you don't have to. So I take 1.05 meters and I times it by 100 centimeters because that's how much is in 1 meter, right? So I change that to 105. So how much wrapping paper is this guy going to need if he's going to wrap the front of the door? 105 times 30, which is what?
3,150.
Thank you. 3,150 centimeters squared. Now I have to focus on my units as well. I have to write the correct units in all of this. So if it's centimeters squared, centimeters cubed, we need to make sure that we write those units down. Okay, is there any questions about that? Not yet? All right. So again, it's not anything different. You've already done, and in fact, I believe you even did some area questions in that chapter as well. So it also says, how much space is there inside the locker for the balloons? Okay. So what am I looking for if I'm looking for space? Volume. I'm looking for volume, right? And how do I find the volume of any rectangular solid? Just like that. Good. Okay, so length times width times height. All right? With my length being 30 centimeters, my width is 40 centimeters, and my height is 105 centimeters. So we multiply that all together, and what do we get? And what are my units? Centimeters cubed, right? Centimeters by centimeters by centimeters, centimeters cubed. Everybody okay so far? Yeah? All right. So my next order of business is going to be is to show you how I want to convert now units squared or units cubed in relation to using areas and volumes. Okay? So, for example, 1 meter has how many centimeters in it? 100 centimeters. So I want to find out how many centimeters squared there are in 1 meter cubed. So what I do is this. I draw myself a quick picture. This is 1 meter by 1 meter. Okay? So how many centimeters are each?
100 by 100.
They're 100 by 100, right? And I find I find area by taking length times width. Agreed? So when I go 100 by 100, what do I get?
10,000.
10,000. So in other words, 1 meter squared is equivalent to 10,000 centimeters squared. That's the easiest way without having to remember how many square centimeters are in something or how many square meters there are. That's the easiest way to remember, is to draw yourself a little picture. So if I wanted to do volume then, add that on. So 1 more meter here. So what is 1 meter cubed equal to? I have to have another 100 centimeters, correct? 1 million centimeters cubed in 1 meter cubed. That's a very, very simple way of doing it.
Oh, because it's 100 cubed, right?
Yep. All right. Now, what happens if I want to convert centimeters squared to inches squared, or vice versa? So let's do that. Okay. So let's do this again. Now I'm going to go. Do you want to copy that something?
Yes, I have it all.
Let's do it like this. That's okay. So 1 inch by 1 inch. Just like that, right? How many centimeters in an inch?
2.54.
2.54 centimeters and 2.54 centimeters. Just like that. Right? 1 inch squared is equivalent to
6.411
6.4516 centimeters squared. So maybe that's on your conversion sheet. That's fine. Maybe it's not on your conversion sheet. At least you can then do it. Okay? So that would be using your metric and your imperial. Any questions about that so far? Haven't done too much, just simply. All right, look at page 24. Page 24. So we looked at just basic area so far and volume, which is going to give you a lot to work on. Well, let's talk surface area. The surface area. Let's take
What page? 24.
24. So I'm going to take a shoebox, for example, and I want to find the surface area of the shoebox. Okay? How do I find the area of the front face? Length times height. And how many of them are there? 2. There's 2. So 2L times 2H. And what about the sides of the shoebox? Width times height, how many are there? 2. Okay. And then what about the top and the bottom? And so I go 2L times 2W. So to find the surface area of a rectangular solid, I go 2 times L times H plus 2 times W times H plus 2 times length times width. Straightforward, right? There's not much else to it. So all of the second section of this guy is working with surface area. Okay? Now you have all these equations. You will be given all these equations if you have your formula sheet. They're all on the back of this formula sheet. This guy I like as well as any of these formula sheets that I've seen in terms of volumes of and surface areas of all your objects. This is a really good sheet. Okay? Now, I do want to talk about the surface area of, well, I'll start with the cylinder. So, let's say I had a soup can. Okay? And I want to find the surface area of the soup can. So I'm going to break it into two parts, the top and the bottom, and then the label on the soup can. Okay, I'm going to break it into two separate parts. So how do I find the area of the top and the bottom? Pi r squared. How many of the tops and times 2? So I go 2 pi r squared. So far so good? Okay? And that's provided I know the radius of the can. Right? And then I got the height of the can here. So this is the label itself. So how do I find the surface area of that label? Go ahead.
Height times circumference.
Say that again.
Height times circumference.
Length or height, let's say.
Yeah.
Times circumference. Yeah. We agree? Disagree?
Agree.
I agree as well. Circumference is found by taking 2 pi r. So that label looks like that, right? That's what the label on the soup can looks like. If I take it off, it looks like this. Correct? So even though it's a piece of paper, and it should be length times width, as long as I know the radius of it, I can find the circumference around this guy, right? And then times it by the length of that label, the height of it. So this is the surface area of a can. So far, so good? Okay, now, again, I need to know the radius or the height in order to do that. Okay? If it says find the lateral surface area of the can, that is just the label itself. You don't include the top and bottom. The lateral surface area does not include tops and bottoms. Okay? So when you see it written in your questions, that's what that means. So far? Okay. Now, what happens if this can becomes a cone? So I take it like this, and I go down to here and back up to here. And I want to find the surface area.
Half the circumference
Half the circumference?
times the height.
Close, not bad. It's good thinking. Okay? So I have to do the surface area of a cone a little bit different. Okay? So if you're following along on this, I'm just going to flip it upside down for now. So, starting with the bottom of the cone, the opening of the cone, just like an ice cream cone, the opening. How do I find that area?
Pi r squared.
Pi r squared, right? So now I need to find the area of the cone itself. Okay, so I need to find the area of the cone itself. Correct? Here. It's good condition as it is. Everyone? So there's my cone right there. That's a little funny, of course. This is up. Right. So there's your cone. That's the shape of your cone, right? So again, okay, how many of you ever had a drumstick before?
That'd be odd.
Ever had a drumstick? It's one of my favorites for the record. We can find ice cream, guys. Drumstick, right? So you take the label off the drumstick, and again, it goes from this to that. Right? The label just ends up being basically a piece of paper again. It's just in the shape of a cone on the base of it. Okay? So I need to find it. Now, what I have here is a triangle. Does everybody see the triangle that I made? The height and the radius. I'm also going to put this guy right here. That guy is called the slant height. Now you only need to work with slant height in terms of area. Okay? So to calculate then that cone, again I got to use that pi r s. Alright? So I've got pi r squared plus pi r s. This is the surface area of a cone. Now, if it's an ice cream cone, they're going to just say, well, what's the lateral surface area of it? I don't include the top, because there's no top on it. So you put the actual ice cream inside it, right?
Then it'd be the inside area.
Okay? So it'd still be the area of this, okay? All right? So any questions about that, guys? So that's just surface area. Yeah, go
If
ahead.
you're not provided like the length of the S.
All right. So then how do I solve it? That's a great question. I use the theorem, right? R squared plus H squared equals S squared. And then you get the slant height in that case. Make sense? So if it's not given to you, you've got your triangle and you create the Pythagorean theorem. Okay? That's the only two I think. Oh no, I shouldn't. We should look at the ice cream itself. It's a ball of ice cream that fits in there. What if I want to find the surface area of that ball?
Like of the sphere.
So the surface area of a sphere is what I'm looking for. What is it?
4 pi r squared.
Surface area equals 4 pi r squared. Is that right, Jamie? Surface area of a sphere? Good. Good, good. Okay, good job. There it is. Okay, so today we want to attempt to get through 2-1. And then for those of you that zip through it, because I find this easy. Okay? But then you can get on to 2-2. And then tomorrow I'll show you 2-3, but we'll work on it 2-1 and 2-2 tomorrow and finish it up.
Is it next Friday?
We haven't set a date yet.
Oh.
We're gonna see how fast we go through this. You're missing school on Wednesday, so we may not be able to get to that test till the start of next week. Okay, any questions? Yes, Kylie?
Am I gonna miss the last one on Friday?
Yeah.
Can I go downstairs to get my
Yeah. Okay. If there's nothing else, I want you to get to work.